Okay, a video on finding mins and maxes or extrema, review packet number 1. This is a straightforward application. Take the derivative, set it equal to 0, and you find the critical points at 5 and 7 because the derivative nicely factored. Now, the last thing you should do before you move on is it undefined at any point, but with x squared minus 12x plus 35, we don't have any trouble. So these are our two critical points. We then test the derivative to the left of 5, and we find it positive. Pick a number between 5 and 7, 6. This would be negative. This is positive, so it's negative, then positive. Therefore, by the first derivative test, which is perfectly fine in this case, 5 would be a local max, and 7 would be a local min. You can also, even though it's not asking in this second in this question, use the second derivative test. The second derivative is 2x minus 12. At 5, it would be less than 0, which would mean the function is concave down, which leads to the conclusion that it's a max. At 7, it's greater than 0, so it would be concave up, and that would be a min. So let's do a slightly more difficult one. Find the extrema for f of x equals x to the 2/3. Here, the derivative is 2/3 x to the negative 1/3, which is 2 over 3 times the cube root of x. Does it equal 0 anywhere? No, but it is undefined at 0, therefore 0 is a critical point. Don't forget this step. So at 0, I test it. Just going to be a little careful with this. If I'm negative, the cube root of any negative number is negative. So f prime of x is negative to the left of 0 and positive to the right. So I graphed this function. You'll have your calculator on this test, so let's watch it. And there it comes, our famous cusp at 0. And of course, to the left of 0, it's decreasing, and to the right, it's increasing. But 0 is a local and global minimum. So don't forget to test critical points, derivative equal to 0 or undefined. Same thing with the second derivative in finding concave up and down and inflection points.